lesson 217, the unit rate as the scale factor. Remember, that's K. Scale factor is K. So we're going to be using this K idea, y over x equals K, now with drawings and images and scale factors. Again, this is chapter 7. You don't have a B book, but you could get to this online in your online textbook. So this is in the B book, which is not in your possession right now, but you do have online access. First example, Ruben created a simple game on his computer and he shared it with his friends to play. They were instantly hooked, and the popularity of his game spread so quickly that Ruben wanted to create a distinctive icon so players could easily identify his game. He drew a simple sketch. From the sketch, he created a sticker to promote his game, but Ruben wasn't quite sure if the stickers were proportional to his original sketch. So you can see the original sketch is here on the left, the sticker, big sticker, is here on the right. How do we know if it's proportional? We have to measure and see if the corresponding lengths, if they have the same constant of proportionality. So is there the same constant when I relate the A side to the A side and the B side related to the B side on the sticker and the C side on the original sketch with the C side of the original on the sticker, and the D side on the original with the D side on the sticker? So yes, we're going to be using rulers in class today to do some measuring. And you can see that I have a ruler up here on my smartboard. Let's see how friendly it's going to be today, to try and measure this side, which is A, this length, which is A. So if I put one end at the tip up here, and I'm just putting it on 1, and it's going over to, oh, that's centimeters. I want to measure centimeters. I'm going to measure inches. I'm going to measure inches. So it looks to me, oh, and this is being projected. So this is a little bit off because the projector is making it actually larger than what it is on your paper. But if you took a ruler and you measured from the top of A down to the bottom of A down here, you would see, so I'm not going to be able to use this ruler here, and I did measure it beforehand, that A measures 1 inch. So the original sketch is 1 inch here. And then I took a ruler and I measured A, like it's lined up over here on the sticker, and it actually measured 2 inches. So it looks to me like the sticker should be twice as big. Then I measured B, and across B here, yep, that was 1 inch. So I'm putting it into a table. And yes, when I measured B on the sticker here, this was 2 inches. So a 1-to-2 ratio there. Actually a 2-to-1 ratio because it's always scale over the original. And yes, the scale drawing, the sticker is twice as big as the original, 2-to-1. It's a 2-to-1 ratio. C, this measured to be 7/8, not quite 8/8, not quite a whole inch. And when I measured C over here on the sticker, when I measured that length, I got 1 3/4 inches. And I measured D, this bottom side here, on the original sketch, and I got 3/4 of an inch, or 6/8 if you want to read it that way. You could say 6/8 of an inch, or 3/4 of an inch in lowest terms. And D did measure to be 1.5 inches. So is this proportional? Is it truly an enlargement? So measure all the corresponding lengths. So A corresponds to A. B corresponds to B. C corresponds to C. D corresponds to D. That's what it means by corresponding, matching sides. So don't measure D and then compare it to C in the original picture. So check to see if they all have the same constant of proportionality. To get that constant, it's the scale over the original. Well, this is 2/1, which is 2, y over x. So my scale drawing is my y, my original is my x. As you see here on the table, I labeled that. So y over x equals k, constant of proportionality 2. 1 3/4 divided by 7/8. And yes, if you do that mathematics, it is a constant of 2. 1 3/4. So that's 7/4 divided by 7/8. Well, that's 7/4 times 8/7. And yes, they are in a 2-to-1 ratio. As you can see, that math does work. And then 1 1/2, the last one, letter D, to that 3/4. Yes, 3/4 and 3/4 does equal 2 if you double it. So it is a 2-to-1 ratio. So is it an enlargement? Yes. Does it have a constant of proportionality? Yes, k was 2 here. So it is an enlargement. The answer is yes. The next example. Steps to check for proportionality for a scale drawing in an original picture. Measure the lengths of the scale drawing. I did that on the little Rubin cube there. And record it in Y. Then measure the corresponding lengths of the actual picture. So the actual picture, and put it in X. Because the scale is Y, the actual picture is your X. Then figure out if they do have a constant of proportionality. I did those 3 steps. So the key idea is here, the scale factor, which we call the constant of proportionality, which is also called the unit rate. So now that k takes on another name. We've heard it as the constant rate, the unit rate, the constant of proportionality. It's also called the scale factor. So k is also called the scale factor. Scaling by factors greater than 1. So if your scale factor, like 2, makes an enlargement, scaling by factors that are less than 1 makes a reduction. So exercise 1, we are not going to do this in the video. We're going to do exercise 1 in class. So we're going to leave that blank. So I'm going to go on to example 2. Use a scale factor of 3 to create a scale drawing of the picture below. You're going to need a ruler to do this. Hopefully you have some kind of a ruler at home. If not, use a straight edge and do your best guess. But I really, really hope that you have a ruler, a math tool at home. Use a scale factor of 3 to create a scale drawing of the picture below. A scale factor of 3, which means, as you can see my little note here, multiply all of the dimensions by 3. So I found A, when I measured A with my ruler, that this was 1.5 inches. This length here was 1.5 inches. So 1.5 inches times 3, I'm going to make a little table over here. A, to make my new A, I'm going to have to take 1.5 inches and multiply it by 3. Well, that gives me 4.5 inches. So my new A has to be 4.5 inches long. B, when I measured this little B section here, was 1/2 inch. So 1/2 times 3 gives me 3/2, or in lowest terms or simplest form, 1.5 inches. 3/2 is 1.5 inches. D and C are exactly the same. They're tiny. They are 1/4 inch. So C and D are both the same. They're 1/4 inch times 3 would give me 3/4 inch. Okay, so I'm going to try to do this with my ruler, and it may project a little bit larger than what will fit on the paper here, but we'll see. With the projection, it does make it a little bit larger. As you know, the screen is pretty big, and it's much bigger than the computer screen that I have because it's enlarging it in an equivalent ratio. So we're making an enlargement because I'm multiplying by 3. My scale factor is 3. I'm multiplying everything 3 times larger. Okay, so let's see what we can do here. We're going to make a side, which is 4.5 inches. So I'm going to make my A side 4.5 inches long. I'm going to make it yellow, just like it is there. So 4.5 inch line here. 4.5 inch line there. So my A is 4.5 inches. B has to be 1/2 inch wide, which then when I multiply it by 3, I got 1.5 inches. So I have to rotate. Gotta turn that off. So I need to rotate my ruler here and hopefully make a nice 90 degrees there. And I need to make B's length here from the top to the bottom. I'm going to try to make it 90 degrees here, 1.5 inches. So be careful that you're starting on the edge of your ruler. So 1.5 inches. And again, I'm going to use my ruler. Hopefully you have a ruler. And 1.5 inches here. 1.5. So that's the length of B. C is going to be 3/4 inch, and D is 3/4 inch. So C is blue, so we're going to make C 3/4 inch. I can leave that there. 3/4 inch. So 3/4 inch, this would be 1/2 plus 1/4 would give me 3/4 inch here. Oh, go all the way down. 3/4 inch there for my C, and my D, which is also 3/4 inch. So my D is 3/4 inch. So up to the 3 there. So now I've got the color. You don't have to do it in color. I'm just trying to be fancy here. And I'm going to take my ruler and measure those same things over here. So my 1.5 inch for 1.5 inches for the B. And then the 3/4 inch for the C. That's the way that looks. So make sure your pencil's lining up carefully. And 3/4 inch for the D. Winging around there. Okay, so my ruler's upside down, but that's okay. So I'm just going to connect point to point there and make my flag that was what it was that I was making there. And it should come out to be 3 times larger. And yes, you could color it in, but that is the proportional flag drawing from my original flag here that had dimensions of 1.5, 1/2, and 1/4 are now 4.5, 1.5, and 3/4. So that's what my flag would look like. If you want to color it, feel free. The next one, where we're going to actually reduce it, so it's the same flag here in exercise 2, we're going to make it half the size. We're going to do that part, exercise 2, in class. So we'll be doing that one in class. So let's go to the last page here. Example 3 says, your family recently had a family portrait taken. Your aunt asked you to take a picture of the portrait using your cell phone and send it to her. If the original portrait is 3 feet by 3 feet and the scale factor is 1/18, of a foot, draw the scale drawing that would be the size of the portrait on your phone. Well, we know pictures on a phone, very small. This big portrait was 3 feet by 3 feet. So some notes here that I'm going to make, a sketch and notes. I know that 3 feet equals 36 inches. And 36 inches times that scale factor, I'm reducing it, tiny, 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 times 1/18 would give me the fraction, oh, look at that, it cross cancels. It would give me that it's now going to be 2 inches, not 3 feet, it's going to be 2 inches by 2 inches. 3 feet by 3 feet, that's a square of, so our family portrait there was a square. Now it's going to be 2 inches by 2 inches. So using my ruler, I'm going to, again, make a sketch here, 2 inches by 2 inches. And I'm just going to try to draw a square. So if I have a line here, from 1 inch right to 3 inches is 2 inches. And I'm going to swing my ruler 90 degrees. Whoop. Swing that ruler 90 degrees. And how do I know it's 90 degrees? Look at this little degree thing on here. That's pretty cool. That's 90 degrees. And I'm making a 2 inch. So I'm going to go ahead and make my purple square here. 2 inches. Oh, that's not inches on that side. Silly me. Got to move my ruler over. Got to use the inch side, not the centimeter side. Jeez. Got to be careful to read your ruler. Moving it over. I'm going to create that same line over here at 90 degrees. Try to make it 90 degrees so it does come out to be a square. We know squares have 4 90-degree angles. Put it back to 0 here. There we go. And then so now, what are the dimensions of my little picture that's on my phone? It's 2 inches by 2 inches. It's a 2-inch square, which that would fit on a phone. That makes sense. Example 3. John is building his daughter a dollhouse that is a miniature model of their home. The front of their house has a circular window with a diameter of 5 feet. Ooh, big window in the front. Big circled window. If the scale factor for the model house is 1/30th, so he's making a dollhouse that looks just like their house, that's 30 times less as big, so it's 30 times smaller. Make a sketch, so 1/30th. Make a sketch of the circular dollhouse. Well, I know that 5 feet times 12 inches per foot, 12 inches per foot, right, would give me 5 feet would be a total of 60 inches. So I'm converting it all to inches. So 60 inches times 1/30th. Well, 30 goes into 60 2 times. Oh, we've got a 2-inch circle that we're going to make. So we're reducing, yes, a dollhouse obviously is a reduction. So we're reducing the house down to a dollhouse, and we're making that 5-foot window proportionally down to a 2-inch window. It's a circle, so we need a compass. Now, just do your best sketch. I'm going to actually use a compass, as you can see here. Here's my fancy smartboard compass, and I'm going to make a circle that's 2 inches around. Where's my ruler to make sure my compass is opened to 2 inch? Oh, 2 inches around. So my diameter is 2 inches, which makes my radius only 1 inch. Wow, this is a goodie. You got that 1 inch radius open exactly. That never happens. Wow, that was good. So I'm going to swing my circle. Now from side to side, all the way across here, the diameter equals 2 inches. The radius was half of it, was 1 inch. And we're gonna do some more drawings and finish filling in this worksheet in class. That's it for today.